Today we will learn about how to create a grating in a panel in AVEVA E3D. For this tutorial, first of all, we will see how to create a grating, and after that we will create a template and we will refer that through a fittings specification, and by using that fitting specification we will create the gratings further on. Okay, so first of all, here we have a panel. So to create a fittings in that panel, first of all we have to go to plates, and after that we have to click on fittings. Okay, after that we have to click on this panel, and after that this window will pop up. Currently I have put up a specification component under the deck hatches spec. I will show that later on just for reference, and in this case our width of this panel is 1200 and the length of this panel is 2 meter. So we have to update this accordingly. So 2 meter length and the width will be 1200. After that we will click on apply and we will place this fitting perfectly here. Now as you can see that our template of this grating have been positioned perfectly, and this is a grating. This is a proper grating. Currently it has been created by using panels. You can also create it using Gen 6, but if you create it using Gen 6, then for heavy models it will make the model heavier. Okay, so I prefer it by creating using panels. So now what we have to check, we now will check how to create this thing. So for that we will use the template creation method. Currently as you can see that we are under the structures. So for that, to create our template world or something like that, we have to go to design templates. Okay, so first of all, after clicking design templates, you can see that the template browser window has popped up. Now if you go to model explorer, okay, you can see that there are different TPWL or template worlds, as you can see. Okay, these are different. These are the default template worlds built up by AVEVA itself, and these are the self-created ones. To see all these template worlds and everything like that, first of all you have to go to project. Okay, after that you have to go to options, and after that under the configuration tab you have to go to explorer settings, and after that you have to uncheck this hide non-user system data. Okay, so these are the non-user system data, so you have to unhide this. Okay, generally in PDMS all these data is automatically visible, but in E3D you have to unhide that to see all these template worlds, application data worlds like that. So currently I have created this template world. Okay, to create a template world, just you have to click on this template world, and after that there is this template area. So after clicking on this template world, if you click on this template area, a template area has been created. Okay, and after this template area, what you have to do, you have to click on this template creation. So after that a template will be created. Under this template nothing will be there. Currently this is a created template. As you can see, this is our template. Okay, this is our template in this case. So just let me create one new template to show you all that after clicking this, we have to click on this add properties and add points things. You can select pfits or something like that if you want to give the generic type or something like that. If you want to copy already created some designs into your template, then you will click on this copy a model to this design template. Suppose you have created a model using equipments or using certain primitives or something like that, and you want to copy that thing into a template, then you have to click on this copy model items. Okay, but currently we don't require that. We will create our template from zero. So after that, if you click on OK, then as you can see that the template has been created, and under that template there are two things, one DPAC and one DDAC. That is the data point set and the data set. Okay, so this is how you create a template. This is how you create a template. Now under that template, what you have to do, you have to define all the required geometries. Okay, so in case of our fittings, first let me remove this thing from here. Yeah, and just focus on this template for now. Yeah, perfect. So as you can see that under this template I have defined 4 panels to define the end perimeter of this grating. Okay, this defines the boundary of the grating, you can say, and this to the center bars, and other center bars will be copied by using this thing, this pins. Okay, so for that what you have to do, first of all you have to define panes. I have defined the basic 6 panes which will be created for any such templates. Okay, if you want to create a grating using these templates, first of all these things that have been defined here, this 6 panels will be created at first. Okay, these 6 panels will be created at first. So just let me show you how to create this one. So after hitting on this template, suppose I have created this template. So after hitting this template, what you can do actually 2 things. First of all, you can go to again structures, and using this plate or panels, you can just define your plates or panels accordingly under this template. Okay, or what you can do, what I have done actually is by just giving this points, just by defining all these points. Okay, I have done this just by defining all these points. So first of all, what you have to do, you have to create all these required panels. So in case of a grating, you have to create 4 panels to define the boundary of the grating, and the 2 panels which will be located in the center for the center rods. Okay, after that, what you have to do, you have to create the property definitions. Okay, for creating the property definition, what you have to do, you have to go to this template browser, and after clicking on this template world, as you can see that this is our current template that is being shown here. Okay, so this is the pane fittings template. So if you click here and click on property definitions, as you can see, there are 5 properties defined by me, that is grating length, grating width, grating thickness, crossbar center to center distance, and bearing bar center to center distance for our standard grating. And this is the new template that we have just created. And after clicking on this template, if you click on this property definitions, as you can see that there are no such properties defined, because just we have created this template. So just let me show here by clicking on this template, and after clicking on property definitions, what you will do, just like you create something in Paragon, in category in Paragon, you will define a description, you will define a D key, and you will take design parameter or attribute or expression, something like that, and giving the number and default values. So after that, you will define all the required parameters, all the required design parameters like that. Okay, it can be design parameters in a different case of templates. It can be expression, it can be attributes, something like that. It can be string values, something like that. But in our case, all these 5 parameters are design parameters. One is grating length, one is grating width, grating thickness, crossbar center to center, and bearing bar center to center. All these 5 parameters have been defined by which procedure? By clicking on this template, and after that clicking on this property definitions tab. Okay, and after that you will fill all this, and you will just click on include, and one by one each and every properties will be included. And if you want to change anything like that, so you will just do it by replacing this existing property. Okay, so after all these properties have been defined, what we have to do, we have to parametrize. We have to parametrize all of these panels that we have already created. So we have already created 6 panels, 4 for the grating boundary and 2 for this cross members. Okay, these rods. So we have to parametrize it, but because currently, as you can see, if you go here and if you click on this pave points, you will see that there is a certain position that is already defined. Certain positions, this 950 is our default value. But if you create the grating fittings by using these templates in its current format, then you cannot change this value. You cannot change this value because it is currently only a value and it is not related to any design parameters. Okay, so for that we have to parametrize all of our required primitives, in our case all our required panels. Okay, so for that what we have to do, again we have to go to template browsers, and after clicking on this template, what we have to do, we have to click on this parameters, this modify parameters tab, and as you can see, this template parameters tab has been displayed. This is the standard template parameter tab. So as you can see, again we have to go to model explorer, and this is our pane number 1. Okay, so as you can see that in this pane number 1, just let me differentiate this attribute and place it here so that we can understand it in a better way. So now as you can see that the position with respect to owner is a certain position that has been defined by me. This is nothing but a given number. Okay, but we have to parametrize this. We have to parametrize this one. So for that we have to write an expression for this parametricizing thing. Okay, this is the pane. Okay, this is the pane, and this window has been displayed by clicking on this modify parameters tab. Okay, so under this modify parameters tab, as you can see, all of these panes that we have already created is shown here, along with the P loops or pane loops and pane vertexes. All these things have been shown here. So we have to define the rules first. So after clicking on this pane, as you can see in this area, you will see all the rule tabs. Okay, currently we have only defined this position rule. So after clicking on this position rule, this attribute rule dialog box will be popped up, and under this attribute rule dialog box we have to define our expression. Okay, now one important thing we have to discuss, and that is how to access this data points. How to access these data points. If you go here, these are the 5 design parameters that we have already defined through this property definitions window. So now to define all these rules, we have to access these data points. Okay, so to access these data points, there are several ways. So now suppose we will define a rule for this panel. So this panel is under the hierarchy of this template. Okay, so the panel's owner is template, and this DDAC or this data sets owner is also this template. Okay, so both the panel and the data sets are having the same owner, that is the template in this case. So in this regard, this data set is the current data set of the panel. One data set is the current data set of a primitive or panel or gensec if both the gensec or primitive or panel and the data set belong to the same owner, in this case the same template. So as you can see that here, for current dataset real properties, you can write CDPR. Okay, current dataset property real, CDPR, and this is the grating width, and we have to delete this template because this is the current dataset for the pane. Okay, so we can just write it pane here, and after that we can click on test expression, and as you can see, the current data set reference of the width, the grating width of the panel has been taken. Okay, has been taken. After clicking on this test expression, if there is some error, then it will be displayed in the results tab, but currently it is perfect. So now if you want to create any template, generally you will require only this current dataset real property values. Okay, this is the current dataset real property values. Why this is the current dataset? Because both the panel, current datasets of panel, so this is the panel and this is the dataset, both are having the same owner. That is why this will be the current dataset property real. After that we will define the D key of this design parameter of panel, because this is the current dataset of panel. Okay, now again there are different kind of datasets. There are currently 3 kind of datasets. One is current dataset, one is local dataset, and one is template dataset. So we have already defined the current dataset. So now let me define what is a local dataset. So suppose this template is under the hierarchy of this template area. Okay, this TMAR is the template area. So this template is under the hierarchy of this template area. Now this template is having a locality. Okay, this template is having a locality. Suppose if this template contains a DDAT or something like that, then this template can also access that value as well. But in that case, you have to change this CDPR to LDPR, because this is the common locality of a template. So just let me close this window for a second and open this DDAR. This is the dataset area. This is the template area and this is the dataset area. You can create it through the command window. Under this dataset area, you can also define another dataset. Okay, so now as you can see, this is another data point. Okay, but this data point is not under the same hierarchy as the previous data points. Okay, this is under a different hierarchy. So this data point, as you can see, is having the D key of TLEN. Okay, but if you just click on here in the panel and click on here, again we have to let me change it to what we have changed before, that is CDPR of PANE or pane. Okay, and test expression. Now it is correct. But now suppose we want to access this data point. Okay, so this data point is having the D key of TLEN. Now if you click on this position and if you go here to access this data point, what you can do multiple things. First of all, you can write LDPR, that is the local data set. We have to give the D key of that data point, but this will be the local data set, not of panel, because of panel you will get this error. So this will be the local data set of template, because this is in the locality of the template. So you have to write it here TMPL. So as you can see that this is the local data set of template and it is currently accessing the value from this area. Okay, but for that you have to do one more thing. Just let me change it to gwidth, and as you can see that now it will take the value from here. Okay, because this is also in the locality of this template, so you can access these values in multiple ways. You can just write it as CDPR of pane or of something, of gensec, of primitives or something like that. So it will access because it is the current data set of that particular element, because both of these elements are owned by the same owner. And if it is not owned by the same owner, then also you can do multiple things. First of all, you can refer this by LDPR of TLEN of template, because it is having the same locality. It is having the same locality. Why it is having the same locality? Because suppose if you see here, this is the common data set area and this is the template area. Under this template area, one hierarchy down is template. Under this data set area, one hierarchy down is data set. Okay, so it is having in the same locality but not under the same owner. So you can access this by writing LDPR TLEN of template. You can access that data by writing LDPR TLEN of template. But to do that, you have to do one more thing. You have to click on this TMPL, and if you click on the attribute tab, there is the attribute tab, I forgot. So just let me close this and open another command window. So as you can see that you have to mention the dataset reference array. Okay, this is very important because this dataset is not owned by this template or this template area. Okay, this is a different common dataset kind of thing that is owned by a different dataset area. So you have to define the reference of this thing. Okay, under this ddrf array, generally it is unset. So by using command window, you can define this like ddrf array space backslash, giving the name of this dataset, what I have done here. If you want to define multiple number of datasets, that can be also done by giving another space and backslash and giving the name of the for the datasets. Okay, so after doing this, only you can see this thing. Suppose if I delete this and now it is unset. So now just do one small save work, and now if I go here in design templates and in parameters, as you can see, if I click here, now if I write it here as LDPR TLEN of TMPL, you will see that it will show us an error. Why is this error? Because as you can see that the TLEN has not been shown here also. Why it is like that? Because the reference is not there. The reference is not there in the DDRF array. So we have to give the reference. So how we will give the reference? Just by through command window. So our name of this dataset we have to give here, and after that, as you can see, this grating DDAC has been shown, and currently if you again click here, you can see that this TLEN design parameter has been shown here. So first you have to give the reference to the template under the DDRF array if you want to define a common kind of datasets. In which cases it will be required? Suppose you want to create multiple templates for structural joints or something like that. For that, you can create this common datasets for storing the attached owning section parameters like that. Because in other cases, if you want to create different datasets, so you again and again you have to create the same datasets for the attached and owning section parameters, because more or less these parameters will be the same. So in this case and in many other cases, you want to define a common dataset area, and under that a common dataset which can be accessed for creating various templates. Okay, so for accessing all those common dataset areas, after creating this dataset area, common datasets and common dataset point, the last step is the reference of this dataset reference array. Okay, so you have to refer this. Only after that you can see this common parameters. Okay, all these 5 parameters are current parameters that has been defined under this template, and the last parameter is the common parameter that is not under the same hierarchy of this panel. So by this thing, what you have to do now, you have to define all these certain rules. Okay, so I have defined all these rules, and definition of all these rules is actually very easy. So what you have to do, first of all, for creating a template, one very important thing is the 000 point. Okay, so in case of a category creation, the P0 is generally the reference point. SK of any element or something like that just starts from the P0 point. Okay, the P0 is the midpoint of the SK. So in this case also, in a case of a template, this 000 world point, this 000 with respect to world, this point is the reference point. If you create a template far away and you want to use that template while creating another detailed specification or fitting something like that, in that case also the template will be created far away with respect to that owner. So you have to keep this in mind, that you have to create this template with respect to 000 in the world axis. Okay, so here in my case, this is the 000 point. Okay, so I have created all these panes, and as you can see, this is the north. So what I have done, I have defined all these rules, like this is the rule and this is giving the same value. Okay, just I have given the default parameter such that it is matching with this, so that you can just cross check whether your formula is giving the right value or not. So after that, you have to give all this pavement values or something like that, this pane vertex values. As you can see, you have to give formula to all this, else it will not change depending on the design parameter. Okay, I have given all these formulas. This is very simple. After that, this is the last thing that I have defined, that is the negative box. It is required because this panes will be created, but the default panel, the geometry of the default panel have to be removed from its current area. So you can create a negative box or anything like that. And then again, I have defined its position through this expression. And as you can see again, that this expression I have been created using all this design parameters, all this property definitions tab. And you can also do whatever you want using this property definitions tab. So after giving all these attributes, last again we have to do the main task, that is we have to define the repeat rules. So now as you can see that these six panes along with this negative box will be created, and after that the repeat rule command will be activated. Okay, based on what? Based on our definition of repeat rule. So suppose in case of this is our pane 1. Okay, so this is our pane 1. So this is currently defined just in the middle. This is currently defined just in the middle of this pane. Okay, this is currently defined just in the middle of this pane. So this pane will be multiplied in this direction. This pane will be multiplied in this direction, and our pane 2, that is this pane, will be multiplied in this direction. So for that we have to define repeat rules. Okay, how many times it will be repeated and what will be the repeat offsets to define those things. So for that we have to click on this pane, and again as you can see that there is this tab calling this define repeat rule. So after clicking on that, as you can see, you have to define the number of repeats. Okay, so what you can do, what I generally prefer to do is taking an integer value, taking an integer function or nearest integer function. Okay, you can take the integer function as int, or you can take the nearest integer function as nint. Nint will give the lower integer value and int will give the normal integer value. Okay, like that. So you can take both. After that, what I have done is by taking this width of this template, as you can see, this is the LD. Again, you can define the same things, attrib ldpr gwidth of template. Okay, so I have taken the width of this template, I have divided it by 2, and thus I have got the half width of the template, and I have divided it with the center to center distance. And again, if I go to here in property definitions, as you can see, this is the crossbar center to center. This is the crossbar center to center distance. Okay, so after getting this half width, I have divided it with this crossbar center to center distance, and I have taken the nearest integer value of this division. And after that, I have placed it along this y-axis. You can just here check it the axis, and you can see which axis it is going to replicate itself. So here in our case, this is the y-axis, and I have given a certain value 100 mm. Okay, so in this repeat tab, what we have to do, we have to formalize this number of repeat dialog box. Currently we have to give a certain value in this Cartesian tab, but again we have to define this value also. So now this is a certain repeat rule. Okay, so as you can go here, as you can see that this is our repeat rule number 1. Okay, this is our repeat rule number 1. So in this case, as you can see that if I just minimize this, as you can see that this is the north direction. Okay, this y direction is the north direction. So as you can see, under this repeat rule, there is this delta north. So I have to give the delta north value. Okay, we have defined the repeat rule as 100, but I have to again parametrize that 100 by using our design parameters. In this case, this is the crossbar center to center distance, and this will be -100 for this crossbar and +100 for this crossbar. It can be vice versa. You can just create and check whether it is going in the right direction or not. So after that, we have defined this distance in by using the design parameter also. So currently it has been completely defined. We have defined this first pane and defined its repeat rule. We have defined this second pane and its repeat rule. We have defined this pane and its repeat rule. It will be going in this direction like that. Okay. So these are our current repeat rules. After defining these repeat rules, our creation of the template for the grating is perfectly completed. Okay. So now what we have to do? Now we have to take the name of this template. We have to just go to attribute tab and you can get this name, that is pfit tmpl. Okay. So we have to take this name of this template, and definitely you will have different specifications for panel fittings or something like that. This is very easy. So under this last selector, you will create a specification component. And as you can see that under the other specification components, the category reference has been defined. But in our case, there will be no category reference, but will be one template reference. And this template reference will be the name of the template in our case. This is pfit tmpl. So we will refer this pfit tmpl under the template reference tab of this specification component. So after that, we will do one small save work and performing a small get work and save work. Now our template creation is perfectly ready and we are ready to check whether it is working or not. So we will just remove this one, and again we will just add our panel. We will just delete this one. Currently this will show this locked offspring. So for that, what you can do, you can just go here and you can go to manage and modify lock, and after that you can unlock C and below. Okay, so that you can delete this fittings, because in case of this templates, it is by default in a lock status. You can change it also. Currently we are having this panel. Okay, this is our panel in our case, and we have to check whether the already created template has been working or not. So after that, we will click on fittings. We will click on this, and as you can see under this deck hatches SS, this is the deck hatches SS specification. This is the specification deck hatches SS. So under this specification, we will get this specification component. Okay, so this is the specification component naming the template pfit tmpl, and as you can see, this is the panel fittings tmpl. From where it is getting this name, it is nothing but the description of this template. If you go here and if you click on attribute, as you can see, this is the description of this template. So we have referred the name of this template, and through that Paragon is getting this description of this template, and it is populated here. Okay. So again, we will click here, and in our case, the values will be something like 1200 and 2000. So it will be like that. So again, by apply, we will click here. So in our case, it will be rotated. So the length will be 2000 and the width will be 1200. Okay. So after that, again, we will have to click on apply, and we will position this accordingly. And as you can see, this grating has been created perfectly. Just let me add the structural members also. Yeah. Now, as you can see, this grating has been created perfectly. So now if you want to modify this grating, what you have to do, just you have to click on modify and click on panel, and again right click and enter. So now you have to click on this fittings and right click, enter. Now what you can do, you can just change the length of this things or something like that. And again, if you click on apply, as you can see, it has been modified. Yeah, like that. Okay. And again, suppose you have to change, you want to change the bearing by center to center. We have defined the center to center distance or something like that. So as you can see, from default 50, you can change it to something like 50 or something like that, or you can again lower it like that. So all the design parameters that we have defined have been working correctly. And if you click on this fittings, you can see that this is the template. So as you can see that this 6 panes are the primary panes that we have created under our template. So if I open my template, as you can see, there are 6 panes. So these are the preliminary 6 panes, and this is the template rule set, and these are the 3 repeat rules. Okay. So depending on these 3 repeat rules, these 6 panes have been multiplied accordingly as we have defined and created these things. And this thing is intelligent, because if you change these parameters, all these templates will be deleted and a new prompt will be generated, which will create the required amount of panels. Okay, so there will be no need of extra panels or something like that. So if I just change it from 2000 to 500, as you can see, that only this amount of panels have been created. But again, if I change it to 2000, as you can see, a lot more panels have been created. So it is creating in an intelligent fashion in the array method. Okay, so this is how you actually create the template of a grating, and this is how you can refer that template through a specification component and create that grating template by using the fittings tab. Okay, thank you. Bye for now.